So let's take a look at how we balance redox reactions. So these are oxidation reduction half reactions that we are going to add together and balance them. So let's just use the example that we ended on in the last video where we were assigning oxidation numbers, where we said solid zinc reacts with aqueous silver 1 to produce aqueous zinc 2 and solid silver. So we wrote the solid zinc, the aqueous silver 1 producing aqueous zinc 2 to solid silver. We saw that the oxidation number was increasing from zinc to zinc 2, and it was decreasing from silver 1 to silver. So this is the oxidation half reaction, this is the reduction half reaction. So this is where the problem comes from, and I'm just going to use this as an example to balance half reactions. So I'm just going to write it out again. Okay, so first thing we need to do is assign the oxidation half reaction. So this is oxidation. And remember, we said it's oxidation because the oxidation number is increasing. It's going from an oxidation number of 0 here to an oxidation number of +2 here. So now the other reaction is the reduction half reaction. Remember, in a reduction half reaction, the oxidation number is decreasing. So here we're going from an oxidation number of +1 to an oxidation number of 0. So when we balance redox reactions, oxidation reduction reactions, the first thing we need to do is we need to write each half reaction. So that means we're going to write the oxidation half reaction and the reduction half reaction. We're going to balance those both separately, and then we are going to combine them. So I'm just going to write out my steps. I'm going to write each half reaction. I'm going to balance the oxidation half reaction. You're going to balance it by adding electrons. Then I'm going to balance the reduction half reaction. I'm going to also do that by adding electrons. Then I am going to combine the half reactions so the number of electrons cancel. So I'll talk through what each of these steps mean. So first, let's write the oxidation half reaction. So I'm just going to write this oxidation half reaction. So that is zinc solid going to zinc 2 plus aqueous. So when we say we're balancing this oxidation half reaction, what we're balancing is the charge. And the way that we're going to balance the charge is by adding electrons. So electrons are negatively charged. We can't take away electrons. We can only add electrons. So the way that we're going to add the electrons to balance this charge is if the oxidation number is increasing and this side is more positive, then I'm going to add electrons to the side of the reaction that is more positive to balance this half reaction. So if the charge on the reactant side is 0 and the charge on the product side is +2, I need to add 2 electrons to the product side. The point is not that I want both sides to equal 0. In many cases, you will want both sides to equal 0. the point is not that we want both sides to equal 0. The point is that we want it balanced, so we want the same charge on both sides. Because this charge is 0 and this is positive 2, the only thing I can do is reduce this charge by adding electrons to make it be 0. But it's not true that you're trying to get it to be 0 on both sides. It just happens to be 0 in this case. So we balanced the oxidation half reaction by adding electrons. So let's move on to the next step. Balance the reduction half reaction by adding electrons. So here's the reduction half reaction. Silver 1 aqueous produces silver solid. So again, I'm going to add electrons. So this charge on this side is positive 1. The charge on this side is 0. The only way I can have the same charge on both sides is by adding electrons to the more positive side. This is plus 1, this is 0, so I just need 1 electron. So now I have balanced the reduction reaction. Now I need to combine the half reactions so that the number of electrons cancel. So in all of the time that you've been doing chemistry, you have never seen an electron written like this in a balanced chemical equation. The reason for that is because they don't belong there. So we need to get rid of these electrons before we can write the balanced redox reaction. So I need to have the same number of electrons on both the product side and the reactant side. So if I have 2 electrons here, that means I need to multiply this whole half reaction by 2. When I do that, I get 2 electrons plus 2 silver 1 ions gives me 2 solid silver. Now I have 2 electrons on the reactants, 2 electrons on the products. Now I can add these 2 half reactions together. I'm going to add that balanced oxidation half reaction to this balanced reduction half reaction to get the overall balanced redox reaction. So let's do that. Okay, so now I'm going to add them together. The electrons will cancel, and then my final answer is just going to be whatever is added together on the reactant side and the product side. Solid zinc plus 2 silver 1 ions produces zinc 2 ions plus 2 solid silver. So this is the process of balancing redox reactions. So from the top, what we did was we assigned oxidation numbers. We assigned oxidation numbers so that we could determine what was being oxidized and what was being reduced. Then separately, we balanced the oxidation reaction by adding electrons, balanced the reduction reaction by adding electrons, and then we combined the half reactions so that the number of electrons cancel, and then we have our final balanced equation. Let's do one more example. So here is another example where we have tin 2. Tin is SN. So tin 2 ions plus iron 3 ions produce tin 4 ions plus iron 2 ions. So the first thing we want to do is assign oxidation numbers and then write the half reactions and balance them and add them together. Okay. So first let's assign oxidation numbers. So these are all monatomic ions. Monatomic ions have the same oxidation number as the charge of their ions. So this is +2 is the oxidation number, +3, +4, and +2. So I'm not going to go ahead and write all of these out again. What we need to do is we need to see what is being oxidized and what is being reduced. So again, you want to see what are the partners, and they only differ by an electron gaining or losing some number of electrons. So you want to see what the partner is on the opposite side. So here I have tin going from +2 to +4. Well, when the oxidation number increases, this is an oxidation reaction. Iron is going from +3 to +2. The oxidation number is reducing. That means this is a reduction reaction. So now I'm going to write the half reactions. So let's do the oxidation half reaction first. So I'm going to say tin 2 produces tin 4. So here's an example where I want the charge to be the same on both sides. This is an example where it's not 0 on either side. So if the charge is +2 on this side and +4 on this side, and the only thing I can do to change the charge and balance it is add electrons, you want to add electrons to the more positive side of the reaction. So if this is +2 and this is +4, I must need to add 2 electrons to this side. So now I have a charge of +2 on the reactant side and +2 on the product side. So there's the oxidation half reaction. Now let's look at the reduction half reaction. The reduction half reaction is going from iron 3+ to iron 2+. So here I have a charge of +3 and +2. I want to have the equal charge on either side of the arrow by adding electrons, which means I have to add electrons to the more positive side, which means I'm going to add 1 electron to the reactant side. So now I've balanced the half reactions separately. Now I need to multiply the reactions so that my electrons are going to cancel. So here I have 2, here I have 1. Means I'm going to multiply this whole reaction by 2 to get 2 electrons plus 2 iron 3+ produces 2 iron 2+. Now I'm ready to add the 2 reactions together to get the balanced redox reaction. So I'm just going to write them out again. Oxidation, reduction. So the oxidation half reaction and the reduction half reaction . So now my electrons are going to cancel, and the overall balanced half reaction is going to be tin 2+ aqueous plus 2 iron 3+ aqueous produces, this should be an arrow here, not a plus, tin 4+ aqueous plus 2 iron 2+ aqueous. And that is the balanced redox reaction.